Okay, Nina, so it looks like we're not going to be able to Zoom today, so I'm just going to record this for you and post it on Google Classroom. So the A value in any equation represents how skinny or how wide the parabola will be. And so you can see for f of x equals 3x squared, our A value would equal 3. So for that parabola, from the vertex, which is the bottom in this case, you'd go up 3, 1, 2, 3, and then right one and left one to make some more points on your parabola. For the blue one, A equals 1. So what you're going to do is go up 1, left one, and right one, and that gives you the width of that parabola. And then for the pink one, it's 1/2 x squared. So A equals 1/2. So you go up 1/2, right one, and left one. And so the A value, you'll notice if it's a fraction, you get a wider parabola, and the higher the value, the skinnier the parabola. We can also flip the fraction or flip the parabola upside down. So notice for all of these, they're flipped upside down. So if you take a look at f of x equals 3x squared right here, instead of going, I'm sorry, f of x equals negative 3x squared, you go down 3, 1, 2, 3, and left 1 and right 1. And that gives you the sides of that parabola. With the blue one, A equals -1. So A equals -1. And then from the vertex, you're going to go down 1, left 1, and then right 1. Because A is -1. So if it's negative, we go down. And then for the pink, you go down 1/2, left 1, right 1. So the A describes movement from the vertex. So the way you find the vertex, and this is going to be a very important equation here, is that the vertex is going to be at x equals -b over 2a. So the -b over 2a will give you the equation of the vertex. So that is something you'll need to write down, highlight, you'll need it for the test, and you'll need it for the notes, because that's how we know where the parabola is either at its lowest for an upward parabola or at its highest for a downward parabola. And there's a line that travels through the vertex, which is called the line or the axis of symmetry, and that's the line that cuts the parabola exactly in half. So you have symmetry about that line. And so we're going to demonstrate how to find the vertex, how to use the A value, and then that will get us a pretty decent graph of the parabola. I'm just going to try again. Yeah. Okay. So here are the directions for graphing in standard form. I'll just repeat these on each slide so we can remind ourselves how to do it. So the first thing we're going to do is find our vertex coordinates. Well, just a reminder, 2 is going to be A, -12 is going to be B, 10 is going to be C, just like we did in the quadratic formula. So the vertex, the x value of the vertex is -b, so that's a -12, over 2a, 2 times 2 is 4. So the value of x of the vertex is going to be 3. Now to find the y value, well, if you know the x value, to find the y value, you just plug it into the equation. So y equals 2 times 3 squared minus 12 times 3, so that's 12 times x, plus 10. And I believe we get negative 8 here. Do you mind checking that for me?
Yeah, it's negative 8.
Okay. So that means the vertex coordinates are going to be 3 comma negative 8. And the vertex is a point, so you always want to write it as a coordinate. So the point here is 3 comma negative 8. Right there. Can you see that? Okay. So that is going to be the point that my vertex is. Now, the next thing I'm going to do is use my A value to plot 2 more points. What is A for this equation?
2.
A is 2. So I want to show you how that works. From your vertex, you're going to go up 2, and then right 1 and left 1. And those are 2 points that your parabola is going to travel through. Do you want that?
Oh, sure.
Now we already have a pretty solid idea of what that parabola is going to look like because we have, it's like a weird face. We have the vertex, which is in blue, and then we have those other 2 points that I reached by going up 2 and left right 1. So if these points, you can like erase those, but you go up 2, left 1, and right 1, up 2, left 1, and right 1. Then we're going to plot the y-intercept. The y-intercept occurs when x is 0. So if I plug in 0 to my equation, I have y equals 2 times 0 squared minus 12 times 0 plus 10. So that means my y-intercept is just 10. So I'm going to graph 10 right there. And I'm going to use symmetry to find an additional point. Let me tell you what I mean by that. So there is a line that travels straight through the vertex. No! So there's the line. There we go. That travels straight through the vertex. That is called the line of symmetry. All right, we'll do this. So there's a line that travels straight through the vertex, which is called the line of symmetry. And the line of symmetry basically takes the parabola and cuts it exactly in half. And so the reason why I bothered drawing that line is because you'll notice that line of symmetry goes straight through the vertex. You'll notice the 2 points we got from the A value, the 2 red points, are all equidistant from that line of symmetry. But here we graphed the y-intercept. So notice the y-intercept is 3 to the left of the line of symmetry. So you can go 3 to the left or 3 to the right of the line of symmetry, and you'll get yet another point. So using symmetry, you can say, this is my y-intercept on the left. So right here, I have my y-intercept, but also I have what I call the buddy point, which is on the other side. Then, using a smooth line, we can create a parabola. And so that is the graph.
Is the right point 2 or 3? Right.
So it's 3 to the right because the y-intercept is 3 to the left of that line. All right, so let's do another one. It's like worst video ever. Sorry, it's really not my fault. Okay, so let's find the vertex coordinates. So the A is going to be 1 because it's 1x squared. B is going to be 5 and C is going to be -4. So just a reminder, the vertex is at x equals -b over 2a. So -b is -5 over 2 times 1, which is 2. So the coordinates of my vertex are going to be at -2.5. It might be better to write that as an actual decimal so you can more easily find it on the xy plane. So that's how you find the x value of the coordinates. To find the y value, you plug -2.5 into your equation. So it's -2.5 squared, that's for the x squared, plus 5 times -2.5 minus 4. So that'll give you the y value of your vertex. Okay, -10.25. Yeah, just make sure that -2.5 is in parentheses. I'm just trying to do the math real quick. Okay, so that means, thank you, the coordinates of my vertex are going to be at -2.5 comma -10.25. So it's going to be all the way down here. I'm just going to move my graph up. -2.5 and then -10.25 is about right here. So there's my vertex, -2.5 comma -10.25. Now what is A for this one? A is 1. So from that point, I'm going to go up 1 and left, right 1. Up 1 and left, right 1, because A is 1. So I went up 1 and then right 1 and left 1. The y-intercept, again, as a reminder, occurs when x equals 0. So if we plug x equals 0 into the equation, what do we get? So it'd be 0x squared plus 5 times 0 minus 4. -4, beautiful. So our y-intercept is -4. So I'm going to graph -4 on the y-axis. There's -4 there in green. And so now I'm going to use symmetry to find an additional point. So I'm going to draw in my line of symmetry, which is about right there. Okay, so that's my line of symmetry. So you'll notice your y-intercept is 2.5 to the right of that line. So I'm going to go 2.5 in the other direction to get my other point using symmetry. And then what I can do is draw on my parabola. So notice my parabola has the vertex is the change in direction. It goes from decreasing to increasing. And then it's all symmetric about that line of symmetry line, which is the little red line there. Is that good? Okay. Yeah. All right, let's go ahead with this one. Let's find the vertex coordinates. So we do x equals negative b over 2a. So negative b is negative 3. What would 2a be for this one? Yep. And then when we do negative 3 divided by negative 1, we get 3. So that is the x value of our vertex. X is 3. To find the y value, you plug it into the equation. So y equals negative 1/2 times 3 squared plus 3 times 3 plus 1. Okay, so that means the coordinates of our vertex is 3 comma 5.5. So I'm going to go ahead and put 3 comma 5.5 on my graph. Let me make my graph a little bigger. Three comma 1, 2, 3, 4, 5.5. What's a? Good. A equals negative 1/2. So from my vertex, I'm going to go down 1/2 and then right 1 and left 1. Down 1/2, left 1, and right 1. Okay, so notice I just went down 1/2, very small. Plot my y-intercept. What's the y-intercept? So the y-intercept occurs when x is 0. Yep. So I'm going to graph a y-intercept of 1. And notice for this one, it had a negative a value, so you went down to get to the other 2 points instead of going up. So I graphed y equals 1. And so notice from the line of symmetry, that was 3 units to the left, so I go 3 to the right, and then I can graph my parabola. So I used symmetry. So notice my y-intercept was 1, 2, 3 units from that line of symmetry, 3 to the left, so I have to go 3 to the right to find the other point. All right, so this one looks a little weird if we take a look. It's y equals negative 2x squared minus 5x, but there's no plus 0. But that doesn't mean we can't graph it just like a normal parabola. So our vertex, as we know, comes at x equals negative b over 2a. So negative b will be 5, positive 5. 2a will be negative 4. So I'm just going to write that as a decimal. It's negative 1.25 is the x value. Now to find the corresponding y value, you're going to plug that in for x. All right, so those are the coordinates of my vertex, negative 1.25 and 3.125. So I'm going to throw that on the graph. I'll make my graph a little bit bigger. Okay, so negative 1.5, positive 3.25. So about right there. And then A is negative 2. So from this point, I'm going to go down 2, 1, 2, and left to right 1. So again, I went down 2 because it was negative 2. Down 2, 1, 2. Left 1, right 1. Yeah, that looks good. All right, what's the y-intercept going to be? Yeah, because it occurs when x is 0. So that is right here. 0, 0. And then we can draw our line of symmetry. Okay. And then you can see I have a point a little over 1 to the right of that line of symmetry. That's my y-intercept. So if I go a little bit over 1 in the other direction, I'll have another point to graph. And when you make your parabolas, you have to make them curvy, because they're supposed to be a smooth curve. All right. Do you have any questions? Okie dokie. Nina, I'm sorry we had to kick you, or you got kicked off. Not what I had intended today, but here you go, and the assignment is posted.